All right, so we're graphing this parametric equation. We had our x equation, x equals 3t squared, and our y equation, y equals 2t. I had these t values. I plugged them in, and then I graphed those points. So I graphed this ordered pair. This ordered pair. Oh, that makes that super ugly. This ordered pair, this ordered pair, that ordered pair, that ordered pair. It gave me those dots. It went from there. I graphed it between -2 and 2. So I started there and ended at 2. Those were the two time values. Which point did I start with? Well, the -2 value. When time was -2, I graphed the point 12, -4. So I plotted this point down here at the bottom. I started there, and then I made this dot, and then this dot, and then that dot, and then finally I ended up with that dot when time was equal to 2. When we graph those dots, we can make an arrow on this parabola. And so I'm going to show the direction that we graphed this thing in. You don't need 4,000 arrows. I'm just trying to show you what's happening. That is the way I connected the dots. I started down at the bottom and worked my way around. Parametric has a direction as we make our graph. Questions on how we did that? We can graph this in our calculator. So go ahead and break your calculator out real quick. We are graphing something different. So I'm going to hit the mode button. And just like before when we changed the mode to polar, now we are changing the mode to parametric. And so I hit the mode button, and I'm going down here to this list, and I turn on parametric. Now when you turn on parametric and you hit the y equals button, it looks a lot different. It's letting you type in two equations. So if you look here, for my blue line, I have an x sub 1 equation and a y sub 1 equation. I need to fill in both in order to graph it. And so my x sub 1 equation was 3t squared. For my y1 equation, that was 2t. Let's hit the window button because there's going to be some things that matter in this window. I only want to graph what I care about here. Remember that my interval went from -2 to 2. So notice what my t min is and what my t max is. -2 to 2. That's the time I care about. The t step is going to throw you off. If you just hit graph right now, you will probably get a way different picture than what you want. You want to make that t step pretty small. At times it goes a little bit bigger. The t step is how often is it graphing time. And so the smaller it is, the better picture you're going to get. And so something around 0.1 is going to get you the best picture. Everything else is cool. Let's hit graph. There's my picture. Just like we graphed by hand. It obviously went off a little bit if I changed my window slightly and went to like x minima or x max of like 15. You'll see that it stops. It doesn't go on forever. It stopped at 12 and 12 because we set our t min and t max to -2 to 2. Make sense on how we graphed that with our calculators? Staying with bell work. So we're not leaving that problem yet. Staying with bell work. Now we're going to do the last part here. We have those two equations. I want you to use your algebra skills to eliminate the parameter t and create an equivalent equation in rectangular form. Or in other words, solve one of the equations for t and then substitute it into t. That way you're only left with an equation with x and y. Try that real quick. So you're solving one of the equations for t, it doesn't matter which, and then plug it in to the other one so that you only have an x and a y equation left. Try that. Here we go. Using algebra skills. Somebody set this up. What can we do? Remember what our shape was. Remember, it was a parabola on its side. And so keep that in your mind as we go through this. Let's solve one of these equations for t. Mackenzie? Yep, so t equals y divided by 2. She solved for t. T equals y divided by 2. Once you've done that, then we can substitute in. And so we can take this guy right here and plug that in for t in the other equation because that's what t is. So she's now got this. X is equal to 3 y over 2 squared. That doesn't match what we normally think about. Normally when we graph with y by itself. And so right now it looks kind of funky. What could I do then to solve for y? Garrett, what could I do next? If I want to get y by itself now. Get rid of 3, divide by 3, then what? Square root it. We square rooted to get rid of the square. And then what else would I need to do? Multiply by 2. Think about what that shape would be. What would that picture right there get you? Show me with your arm what shape is a square root graph. It's just a teapot. It's just this thing. Is that what we just graphed? What else do I need to include in order to graph that thing? Plus or minus. When we take a square root, it's got to be plus or minus. Without that plus or minus sign, we only get half of our graph, and we want both. Make sense on how we did that? We converted from parametric to rectangular. It's the same thing. Both of them would get the same graph as long as you had your boundary set correctly. Okay, pull out your notes from yesterday. Let's continue on the back side. Yeah, you can put bell work. Continue with the same idea here. Find the rectangular equation of the curve whose parametric equations are x equals 5 cosine t and y equals 5 sine t for the interval from 0 to 2 pi. We're going to graph it by hand and then label its orientation. In other words, what direction is it going? All right. So we are graphing these things. When we graph them, we're not making a T chart. We're making an H chart. Oh, that's cool. Very proud of you, Hannah. This is T. Time is our parameter. We've got an X equation. We've got a Y equation. We are going to adjust here and see what we need. What would be a good starting time here? 0, because it asks us to graph from 0 to 2 pi. So 0. I'm going to keep going until I get to 2 pi. And there's not a perfect number for you to pick in between. It's a t-step here. So when we change the t-step, it's how often are you picking times? And so we get to have a little bit of a say in this, and we need to be smart about it. What would be a good value to plug in? And think about our equations. There it's 5 cosine t and 5 sine t. Pi over 2 would be pretty good, right? You could do pi over 4. If I wanted to get real accurate, pi over 4 would work, but pi over 2 would be pretty good. In addition to pi over 2, I could plug in pi, 3 pi over 2, and 2 pi. So that gets me 5 points. I'm going to have to be smart about what I'm graphing, but I'll use my calculator and make sure that what I have is enough. Cool. So then we're just plugging in. And so to get my x's, I'm plugging into my x equation. X equals 5 cosine t. And so it's 5 times cosine at 0. What is cosine at 0 going to get me? Yep. And so my value is going to be 5. 5 cosine of 0. And then I go to pi over 2. Pi over 2 would be at the top of my circle. I'm doing cosine, so it's 0. 5 times 0 gets me 0. Finish that chart and graph it. See what you get. I've got my different dots here, 5, 0, 0, 5. I just kept plugging in. And so I had 5, 0, 0, 5, negative 5, 0, 0, negative 5, and then 5, 0 again. Again, all I did was take these numbers and plug them into this equation. Then I plugged them into that equation. Which dot did we start with here? 5, 0. This was my first dot. That was dot number 1. And then the next dot was pi over 2. That gave me 0, 5. So that was this dot up at the top. And so my graph is making a circle. It's going in this fashion. And so when I make my orientation, I was going counterclockwise as I worked my way around this circle. I went backwards, at least compared to a clock. No, you don't need to label that as 1. Yeah, it would maybe help you to understand the starting point, but no, we're good. It would be 0 anyways, not 1. Make sense there? So the other thing we're going to do is we're going to write this as a rectangular equation, rectangular equation. Right now it's in 2 separate parametric equations, x equals and y equals. And in bell work, all we did is we solved for t and we plugged back in. And that becomes really ugly here because you have sine and cosine, and we don't necessarily want to do that here. And so this is just a rule. When you're dealing with parametric equations and you see sine and cosine, it would really help if you used a Pythagorean identity. So what Pythagorean identity do we know that's going to somehow connect sine and cosine? Sine squared and cosine squared, right? Sine squared plus cosine squared equals 1. And so when you see sine and cosine, know that you're going to use that identity. I'm going to write that out here. Cosine squared t plus sine squared t is all equal to 1. That's just an identity. What we're going to do is use what we've got and use that identity to kind of get us back, because that's a true statement. What I want to do is I want to plug in for cosine of t. What based on my equations, what could I substitute in for cosine of t? X over 5, where'd you get x over 5, Drew? Divided by 5. If he divides by 5, that's gone. Now all he has left is cosine of t is equal to x over 5. So we're going to substitute in there. We are plugging in x over 5 squared. That's what cosine of t is, and then we're squaring it. Plus, we're plugging in for sine. What do you think I'm going to plug in for sine? Y over 5, because I'm going to divide both sides by 5 over here. That cancels. Sine of t is equal to y over 5. So it's y over 5 squared equals 1. I'm going to square it. X squared, 5 squared is 25. Plus y squared is y squared. 5 squared is 25 is all equal to 1. You could graph it like that, but it doesn't look exactly like how we normally graph it. What else could we do here to make it look a little more familiar? If I multiplied everything by 25, that cancels. I get x squared plus y squared equals 25. Oh yeah, it's our circle equation that we started with. Makes sense on how we got that. It's a little bit strange. Again, when you see sine and cosine, think Pythagorean identities. One more here. Find two different parametric equations for that equation. So basically, we're taking a rectangular equation and are trying to figure out a way to graph it in our parametric. So right now, without giving you a lot of ideas, I want you to try to break that down. So you're trying to use t here. Think about substituting in. Use your graphing calculator and try to get it to match up. And so in general, show me with your arms, what's that shape going to look like? Y equals x squared minus 4. What's that shape going to look like? It's a parabola. What's the minus 4 going to do? Down 4. And so you're going to try to find equations using t that could graph that in your calculator. Take a second and see if you can do that. So we are trying to write this as two equations, a y equation and an x equation. Again, think about what this looks like in your calculator. X equals something, y equals something. I'm trying to write two equations that are going to give me that picture. It's this shape. It's a parabola that's taking me down 4. I want to do that parametrically. Lester, it seems like you've had some success. What'd you do?
I said x equals t.
X equals t. All right, so he said x is equal to t. If x is equal to t, what'd you do from there?
I just did y equals t squared minus 4.
Yeah. That's the easiest one to do. Okay? That one is almost so easy it's dumb. It doesn't make a lot of sense. But graphing it that way, x equals t and y equals t squared minus 4, and I graph that, there's my shape. It's that parabola. My t step is, or my t max and min are a little weird. That's why it's not going all the way through. But that's it. We rewrote that equation as two separate equations, and it gave me that picture. Anybody do something differently? Hannah, do you have the same one when you did that? Okay. What if I did this? What if I said y was equal to t? If I made y equals t, then I would get the other equation. If y is equal to t, I would substitute in for that then and say t equals x squared minus 4. I want to save that or make that equation in terms of x. So what could I do to make that in terms of just x by itself? Add 4. Square root. But square root of t plus 4, what shape is that going to get you? A parabola. So what else do I need in order, or a square root graph? What else would I need to get me the other half? It's plus or minus. And so if I graphed that thing, so we said y is the square root of t minus 4. Is it t minus 4 or plus 4? Plus 4. And so, boop. If I graph that, notice what it's doing. It's giving me the other half of that graph, the t step, so it's throwing me off. But see that where you're getting that shape, you would need the plus or minus to get the other half. All right, here we go. So we are going to do these as whiteboard problems. That way we get some practice and you get some immediate feedback whether you're doing it right or not. And so the first one you're doing is this one right here. X equals t squared plus 5. Y equals t. You're going to fill out this t chart right here, and then given those points, you're going to graph that on your boards. You are going to show a direction as you graph it because you know what the first point is and the second point, etc. You can always check it with your calculator as you go. But get that set up. Show me your answer when you're done. So I graphed each one of those points. I plugged in my t values to get my x's, my t values to get my y's. I've made my parabola because I started with this one at 9, -2. I started that way and made my arrows going around that direction. We're now writing rectangular equations. We're trying to get rid of the t, and so we're doing some substitutions here. Make sure that you have the full picture. Think about what you wrote as your equation and make sure it makes sense for your graph here. It looks like most of us were doing pretty well. Y equals t. So what I'm going to do is I'm going to substitute for t. I'm going to do it this way. I'm going to plug y in right there because that's what t is. X equals y squared plus 5. That is a legit equation. You could technically leave it that way if you know about your conic sections that you did back in your tiered unit. If x is equal to a y squared parabola, y squared parabolas are horizontal parabolas going left and right. Anybody remember doing that? Yeah. Or you could solve for y. If I wanted to solve for y, you would subtract 5. And then what would you do to get y by itself? Square root. Y is equal to, if you just said the square root of x minus 5, would that give you that shape over there? You would need plus or minus to get the top and the bottom half. Same thing, let's try it again. T squared minus 1 and t squared plus 1. I'll help you out here. At -3, you get 8 and 10, and at 3, you get 8 and 10. Just that way, it's one less number to plug in. See what you get. Draw the picture. It's a interesting looking picture. It's not what you would think. We find our ordered pairs. We started here at 8, 10, and then we went to 3, 5, 0, 2, and then -1, 1. And then once I got there, what did I do? I went straight back the other way because those dots are exactly the same. And so my orientation started going this way, and then we kind of rode the same line going back the other direction. So it doesn't really, it's a weird line because my arrows are technically going both ways, but that's how you did it. You traveled one direction, and then you traveled that same line back the other way. That would probably be a good model of something, and that's sliding on a plane. Take that equation now, those two equations, and write them in terms of x and y. And so you're going to substitute. You're solving one of those equations for t and then substituting in. See what you can get with that. We are substituting in here. So which equation did you solve for, x or y? X, it doesn't matter. Somebody said x, so I'm going to do x. So I'm going to get this equation to get t by itself. And so I'm going to go x plus 1 equals t squared. And I'm going to square root both sides. T is equal to the square root of x plus 1. And so I'm going to plug that in here. Y is equal to, instead of t, I'm going to put the square root of x plus 1 squared plus 1. What happens when I square that square root? Y equals x plus 1 plus 1. Y equals x plus 2. Is that what I graphed over there? Y equals x plus 2? Yeah, the only difference is mine didn't go on forever. It was limited. What was my x value had to be greater than or equal to -1? Why is that true? Why did my x have to be greater than or equal to -1 based on those parametric equations? The line ends. Is there any way to plug in, if you plugged into that x parametric equation, is there any way that you could get a number less than -1? If you plugged in this equation, no matter what you plugged in, you're going to square it. And so anytime you square it, it's going to remain positive. And so no matter what number you plug in there, it's always going to be -1 or greater. That's where we're getting that from. I would like to have done another one. We didn't have a bunch of time. Put your